All right, welcome to my maths and calculation class. Here we have a question that says a horizontal bar 0.75 meters long is pivoted at a point of 0.5 meters from one end and a downward force of 100 Newton is applied at right angle to this end of the bar. Calculate the downward force which must be applied at the right angle to the other end in order to maintain the bar in a horizontal position. Neglect the weight of the bar. So let's try to draw what they are trying to say. So this is how we draw it. The question says what? There is a horizontal bar. And we know horizontal bar, this is how horizontal bar is. So this is our horizontal bar. So since that is the main horizontal bar, let me make it very thick. So this is our horizontal bar. All right. So since this is our horizontal bar, they said we have what? Downforce force of 100 Newton. So let's put a downward force here. So this is the downward force is trying to say. So this is the downward force. And they said it's what? 100. The question say 100 Newton. So let's put 100 Newton here. 100 Newton. And the question says what? Calculate the what? Calculate the downward force which must be applied at the right angle. So this is where we have to what? Calculate. So we have to calculate this side. So this side is what we have to calculate. So this is the downward force that we are asked to calculate for. All right, so it continues to say that at a point of 0.5 from one end and the downward force of Newton applied to. Okay, calculate the downward force which must be applied at the right angle to the other end in order to maintain a bar of horizontal position. So what we have to do is that if the horizontal bar is 0.75 long is pivoted at a point of 0.5 from one end and downward force at 0, then what we are going to do is that we have to look at the length. So let's put the length here. So, okay, no, the height. So we are putting the height. So what have to happen is that let's put the arrows here. So we are going to put the arrows here. And then we'll put a line here. After we finish, you will understand it clearly. So there should be a thin line here, Then an arrow here and an arrow here. And then he said the horizontal bar. So this horizontal bar is 0.75 meters long. So this is the horizontal bar he's talking about. So this is the horizontal line he's talking about. So from here to here is what? 0.75 meters. I hope we understand. Then from here to here is 0.5 meters. So that is what we have here. 0.5 meters. So meaning that when we subtract 0.5 from this 0.75, we are going to have what? 0.25 here. 0.25 meters. So when you reach here, you have to know that when we say in calculating this, you use what we call the principle of moment, which the principle of moment states that when a body is balanced, the total clockwise movement about a point equal to a total anti-clockwise movement about the same point. What it's trying to say is that here and this side must be equal. So we use something what we call equilibrium. So we are going to use the principle of moment applied. That is for equilibrium. So this is how it's going to be. What we are going to do is that we are going to say total clockwise movement is equal to total anti-clockwise movement. So meaning that this side, which is this side, should be equal with this side. So this is the formula. So this side, let's start with this side. So this side will be this side. So since this is the subject we are looking for, which is the downward force, then we say what? This times this. So this will go with this. So we have downward force times 0.25 equal to, so you have to be equal with this, equal to this side 100 Newton times 0.5. So this go with this go with this. So 0.5. So what we are going to have is this force, this subject will stand alone. So force equal to, then this times this, 100 times 0.5. So over, once this number is multiplied by the subject we are looking for, which is the downward force, once it's multiplying this, when it crosses this equals, and it has to come and divide all these numbers. So divided by 0.25. Now, what we'll do next is that you multiply 100, you multiply this 100 by 0.5 times 0.5, and then we'll have 50. So it's going to be force 50 divided by 0.25. So our downward force, as this question is concerned, is 50 divided by 0.25 will give us 200 Newton. Will give us 200 Newton. So this is the answer. So at the end of it all, when you put 200 here, 200 Newton here, and you multiply by this figure here. So what moment said that this side, this anti-clockwise is what? The clockwise, which is this side, clockwise is equal to what? Anti-clockwise. So the one at the left, which is 100 Newton with this one, is anti-clockwise. And the one at the right is what? The clockwise. So meaning that when you added this force, which is 200 times 0.25, you can do it with your calculator. 200 times 0.25, you see that you have 50. So at the end, when you multiply 100 times 0.5, will be equal to when you multiply 200, which we have here, times 0.25. So at the end, you are going to have 50. This multiplied by this will be 50, and this one multiplied by this will be 50. So this is how the calculation is done. Keep on following me, like my videos, and share my videos. Bye for now.